Hello friends, welcome to Bhavesh Sir ki class. Today we are going to see video lecture and will enjoy your studies. Hello friends, today we are going to see exercise 4E. Before exercise 4E we shall learn 4 identities. Out of that first identity for today, I am going to explain you how to remember it. First identity is having product of 3 brackets where first term of each bracket is same. What I mean to say here is, you see the first bracket first term is x, second bracket first term is x, third bracket first term is x. So whenever you get such kind of product of 3 brackets having first term same, then it can be written down as x cube plus sum of all the constant terms, that is a plus b plus c bracket closed into x, plus here it will be x square, x cube plus a plus b plus c into x square. Then it will be product of ab, product of bc added to it, and lastly added is c into a bracket closed. Here it will be x, and last term will be product of second term of each bracket, a into b into c. Now, as I told you, I will make you how to remember it over here. You observe this thing very carefully. Here is x cube. Next term there is x square. What do you see? The power of x cube reduces to x square. From x square, here you can see x. X means x raised to 1, and last term no x. So one thing it's clear, that the power of x will go on reducing. And interestingly, you see over here there is no ABC term over here. First term there is no ABC. Now when it is with x square, there is only a, only b, only c. When there is x, there is a product of first two terms, product of second and third term, product of third and first term, and last term is a product of all the three. I hope this part is very clear to you. But remember, you need to know this identity very well.
Start.
Dear friends, I am taking first sub question of question 1 of exercise 4E. You can see here x plus 6 into x plus 4 into x minus 2. Now if you remember what we did in the previous part of the lecture, that we used the identity now x into x into x, x cube. Then if you remember, power reduces x square, but before x square that will be sum of a, b and c. Here it will be 6 plus 4 minus 2 into x squared, plus, if you remember, next term will contain only x, but that time it will be product of this two number, that is 24. 4 into negative 2 is negative 8. You have to be very careful with the signs. We did this sign concept in one of the topic before this exercise. 6 2s are, that is negative 12, bracket closed. Here x cube, x square, now there will be x plus. Now you have to take the product of last three terms, that is 6 into 4 into negative 2. What happens here? You see x cube remains as it is. Simple arithmetic, 6 plus 4, 10, 10 minus 2, 8. So it will be 8x squared. Now here you can see it will be 4x, and product of this will be a negative term. 6 4s are 24. 24 into 2 is 48. So this is your answer. My dear friends, it's not a difficult exercise or not a difficult identity. Only thing is, you have to be very careful whenever there are different signs. Like you see here, 2 plus signs are there, 1 minus sign is there. You have to be ultra careful while solving such kind of questions, so where signs are, multiple signs are involved. Today's second identity, what we are going to understand is a cube plus b cube. I have written second and third identity together because they are almost similar. A cube plus b cube, if you want to understand its identity, then it will be product of two brackets. Out of that first bracket is a plus b. Second bracket will be a squared minus ab plus b squared. Observe this carefully. Here is plus sign, so here is plus sign. There will be definitely one minus sign only in this one, and that is over here you can see. Fine. When I say second and third are similar, then you observe this a cube minus b cube. If I have, then it will be a minus b into another bracket, a square plus ab plus b square. Now observe this sign is negative, here also negative. So you have to remember the identity very well. And connected to this, we are having one question from exercise 4E, question 2, sub question 1. It states that 2x plus 3y into another bracket 4x square minus 6xy plus 9y square. My dear friends, if you observe this carefully, in this identity we went from left to right. This time we are going to apply identity from right to left. What I am going to do, you observe this very carefully. This is 2x plus 3y. This 4x square is nothing else but 2x the whole square minus 2x into 3y. This 6xy is split up as 2x into 3y plus 3y the whole square. Now you compare with the identity a plus b. Instead of a plus b, we are having 2x plus 3y. Instead of a, we are having 2x. Instead of b, we are having 2y. Instead of a square, we'll have 2x the whole square. Instead of a into b, we have 2x into 3y. And instead of b square, we have 3y the whole square. So if I see the identity in a reverse way, then I have to make the cube of a and cube of b. And that will be added because your first sign is plus and second bracket first sign is negative. So it will be 2x the whole cube plus 3y the whole cube. You will get the answer as 8x cube plus 27y cube. This is your answer.
Start.
I'm going to discuss a very special question from exercise 4E. Apparently looks like very difficult one, but let me tell you, it's not so difficult. But before I go into this question, I would like to remind you that if sum of three numbers is 0, if a plus b plus c is equal to 0, then do you recall this identity? If a plus b plus c is equal to 0, then what happens? It happens a cube plus b cube plus c cube is equal to 3abc. Now, why I am just recalling this? Because I am going to apply this particular concept in numerator as well as denominator. Fine, you see the numerator is huge, like x square minus y square the whole cube plus y square minus z square the whole cube plus z square minus x square the whole cube, whole divided by x minus y the whole cube, y minus z the whole cube, and z minus x the whole cube. Now what I am going to do is I am going to substitute say x square minus y square as p, or say for example a, y square minus z square is equal to b, and z square minus x square is equal to c. If I sum up a, b and c, what happens is x square minus y square plus y square minus z square plus z square minus x square equal to 3abc, equal to 0. If I sum up all those things, then its sum is 0. And we know that just now we recall the identity that if a plus b plus c is equal to 0, then a cube plus b cube plus c cube will be equal to 3abc, which is nothing else but 3 into bracket x square minus y square into y square minus z square into z square minus x square. So instead of your entire numerator as this, your new numerator can be written down like this. Similarly, dear friends, if you observe the denominator part, say x minus y I take as p, y minus z I take it as q, and z minus x I take it as small r. If you add p plus q plus r, what will be your result? Your result will be x minus y plus y minus z plus z minus x, and that will fetch your result as 0. So your denominator will be nothing else but 3 into bracket x minus y into y minus z into z minus x. So this is not the final part of the solution, but I have to rub the board and I will just explain you that what we can replace it now. What will be your new numerator and new denominator will look like. Just now we saw, if you remember, this will look like 3 into x square minus y square into another bracket y square minus z square into another bracket z square minus x square, all divided by 3 into x minus y into y minus z into z minus x. 3 in the numerator and denominator gets cancelled. Now x square minus y square is nothing else but x plus y into x minus y. Y minus y square minus z square is y minus z into y plus z, and this is z minus x into z plus x. And denominator is x minus y minus z, and z minus x. X minus y gets cancelled. Y minus z gets cancelled. Z minus x gets cancelled. So your remaining part is x plus y into y plus z into z plus x. Fine. That's a very special question I told you at the beginning. Dear friends, we are going to do super special question of exercise 4E, question number 10. They've asked us to prove that x square plus y square plus z square minus xy minus yz minus zx is always positive. They've said that always positive. There's some error in the question. It should be always non-negative. Non-negative is either it can be 0 or greater than 0. Let us understand how can we prove this. Before going into this particular question, I would just remind you that if I am having say just p, then I can write it down as 3p over 3, or I can write it down as 4p over 4, or I can write it down 10p over 10. It remains as p. I hope you understand this. 3 gets cancelled, 4 gets cancelled, 10 gets cancelled. Now why I am doing so, you will understand in a minute. And one more thing you have to understand, that square of any real number, fine, this property you should remember permanently. Square of any real number is either greater than 0 or equal to 0. If that real number is negative, then square of the negative number will be positive. Square of positive number is positive. Square of 0 is 0. So square of any real number is always either greater than 0 or equal to 0. This property you should know before going into the solution of this. As I told you, we have understood two things. One was I just explained you that if I am having p, then I can write down 3p over p. I can write it down 3p over 3, 4p over 4, or I can write down 100p over 100. It means the same. Now I will enter into the proof part of this particular question, and not so difficult, let me tell you. We start with the proof. They've given us x square plus y square plus z square minus xy minus yz minus zx. Now I explained you something, and am I right or not? You just judge it from your knowledge which we just discussed. My God, what we have done? Oh my God, 2 upon 2, 2 upon 2, 2 upon 2, that is nothing else but 1. Now what I am doing is, observe this very carefully, 1 upon 2. I have taken out 1 upon 2 as a common. So what will be left out in the bracket is 2x square plus 2y square plus 2z square minus 2xy minus 2yz minus 2xz. I hope this part is clear. I have taken the denominator 2 common. Now begins the biggest game of this question. I am keeping 1 upon 2 as it is. 2x square, I'll split it down as 2 times differently as x square. One more time I'll be using as x square. From 2x square I have taken x square. This 2xy, whichever term I am utilizing, I am just putting a tick. Here 2 dots, that means 1 is utilized, 1 is still left. Minus 2xy. From this I am using 1y square. I'm using second y square. I have written down y square as 2y square as y square plus y square. This I'm putting tick because I've utilized that. Plus, sorry, I'll be taking one term from here, negative 2yz. Out of 2z square, I'm utilizing 1z square over here. So 1z square is utilized. Plus z square plus z square, 2z square is utilized, minus 2zx, and 1x square was left out. If you remember, I've put only one dot, so I'm utilizing that also. That will be here plus x square. So all the terms of this particular bracket are all considered in this particular bracket, but they have broken down, like 2x square as x square plus x square, 2y square as y square plus y square, 2z square as z square plus z square. Now I would just like to ask you a simple question, that if I am taking these three terms into consideration, what will be these three terms make as? And if you recall, it is nothing else but x minus y the whole square. This is nothing else but y minus z the whole square. This is nothing else but z minus x the whole square. See this? These three terms make x minus y the whole square. These three terms make y minus z the whole square. These three terms make z minus x the whole square. Now, if you remember, before starting the proof, I said square of any real number is non-negative. Now, this is x minus y the whole square. So, this has to be either 0. It can be 0 if x and y are equal. So x minus y may be a negative number, but square of a negative number can be positive. So this number is greater than or equal to 0. This is square of a number which is greater than or equal to 0. This is also square of a real number which is greater than or equal to 0. So sum of three non-zero numbers, or sum of three numbers which are non-negative, will be a non-negative number. Hence the thing which was to be proven is already we have proven. While writing, you will take little care. I have already taken care into the PDF files. Thank you. Last identity before exercise 4 is a cube plus b cube plus c cube minus 3abc. Very interesting to know this. This particular identity do not have any application in exercise 4e, but there is one question based on the same thing in your solved examples. Fine, so we have to know this identity, and we have to know that solved example also. Identity is a cube plus b cube plus c cube minus 3abc. It will be expanded into two brackets. First bracket will be sum of all the three numbers, which are the three numbers a, b and c. So a cube plus b cube plus c cube minus 3abc is equal to, bracket open, a plus b plus c, bracket close. Another bracket will open, and there you will see sum of the squares of three numbers, that is a square plus b square plus c square minus ab minus bc minus ca. I repeat, a cube plus b cube plus c cube minus 3abc is equal to, first bracket you see only one power, that is a, b and c, each one has one power. Then second bracket we have a square, b square, c square minus product of first and second term minus product of second and third term minus product of third and first term. Now they have asked us something very interesting. I am talking about solved example 18th. They have given us, there is some error in the first part of the question, which I am rectifying over here. First part where they have given the solution part, they have made an error over here. They have just printed C here as it is C. They have printed just C. In the denominator they have a cube plus b cube plus c cube minus 3abc. Now dear friends, numerator we cannot do anything. If you exactly correlate the denominator with the identity written at the top, what can I see in the denominator? I am just first writing the denominator first. A cube plus b cube plus c cube minus 3abc is nothing else but a plus b plus c into another bracket a squared plus b squared plus c squared minus ab minus bc minus ca. And I'm just copying down the numerator as it is. And if you understand this very well, this entire thing will get cancelled because they are the similar terms. So what is left out in the numerator is nothing else but 1 and denominator a plus b plus c. And if you read the question carefully, then value of a is given to us as 2, value of b is given to us as 3, and value of c is given to us as 4. So this will be nothing else but 1 over 9. That is your answer. This identity has only one application, and that is in the solved example. There is none of the question in the exercise which is based on such an identity. So we end with exercise 4E over here.